Hello guys, in this video I'm going to talk about what is RAG in the AI space. I'm going to explain this using this graphic. I'm also going to explain it via code. I'm going to give it like a coding example of how it works via code. But if you would like a copy of this code, there'll be a link below where you can copy and paste this code into Google Colab and run this yourself. Also, will give some mock data that I'm just going to use as an example for RAG, right? I almost said ragging, but yes. And I'm also going to explain what these two images represent in the idea of RAG, right? I'm Shot. I've been an AI programmer for the past 7 years. Data, math, statistics, AI, machine learning. I've been a part of this field for the past 7 years. I've just been very blessed and lucky. Okay, cool. So, yes, let's get on with the show. So, essentially, this is how a basic RAG system is set up. Some RAG systems are a lot more complicated than this, but this is a basic one that a lot of them will follow this general format, right? They might have an extra one of these guys. You might have a bunch of these guys at the end, right? They might have a bunch of LLMs. They might have a bunch of vector databases. There's a lot of different variations that you can do this, but this is just the most basic, simple one that guarantee will work, okay? So the idea is, first step is you ask a question, right? We're going off the basis that RAG is a question asking system. Essentially, you ask a question and AI will answer it. But the question requires some data, right? Like the LLMs, a lot of these LLMs are not trained on your local data. If you have data about your company, about your job, about your life, it might not know this information. So you have to give it this information and then ask your question. That's RAG in a nutshell. RAG is asking a question to an LLM like ChatGPT, Claude, Gemini, and giving it some extra information that it will use to answer your question. And this extra information is usually stored data that you have, right? So now, that's pretty much how it works. It's retrieval augmented generation. That's what it stands for. The R is for retrieval, the A is for augmented, G is for generation. Now, augment means like kind of changing something. So if I were to augment this is augmenting it, right? Now it's sideways. I'll augment it again. It's upside down now, right? I'll augment it again. I twisted it. Augment it again. It's farther from your face, right? Augmenting, all it means is it changes how it originally was. So the data will be in a certain way, right? So let's say the data will say HMB plus vitamin D3, right? If I were to RAG this, it might come out as HMB and vitamin D3, or it might come out as HMB and vitamin D, right? Like there's different variations that will come out. It will not say the exact same thing. It might say a variation of this, but it's still correct. That's kind of what the augment part means. Retrieval just means going inside a database, right? Some type of storage, right? Let's say I have a notebook, right? If I'm searching through the notebook, this notebook is like my database, right? Or another example is your Instagram account. Instagram account has a following, followers, that's stored data, right? Cool. Just to give you an example of what that looks like. Oh, also a book is considered a database too. A book is a old-fashioned, very, very old-fashioned database as well. Just so you guys get the concept of what a database is if you don't already know. And yes, cool. So, and that's pretty much how it goes. So you ask your question, then your question will activate the next sequence, which is you go to a vector database, and in this vector database is a bunch of your data, right, that you have. And in this data, right, the vector database will do something called FAISS. There's other ways to do this as well, like Elastic. I think it's called Elasticsearch is the other one, and there's another one out there as well. But this is just the method of how it searches. Like the heart of the vector database, what makes it so valuable and important is that you can search through these things very quickly. Imagine just a pile of paper. What's faster, searching through a pile of paper or searching through an organized notebook you can just flip through, right? This is more efficient. So that's kind of what the vector database does. It creates a nice, neat database that you can just swipe through like this really quick. And it has like, some points. So you see how I have like things inside here marking it. So like this is like a point. I'm like, oh, okay, I remember this point, right? Or I might have another point here. Where is it? My pen. Oh, there it is, my pen. Like little markers, right? My pen separated this from me. So the idea is that you might have some markers in there, like the pen tells me, oh, this is a particular subject matter, and then the box inside tells me that's another subject matter, right? Just a little makeshift craft to show you how like vector databases are so powerful, because they'll create these little points inside, right? And yes, so it will search through this database, right, to find the information that's most relevant to my question, okay? And then from there, it adds it together, right? So now I'm at this step where I add the relevant information plus my user question and I send that to an LLM, right? This process of combining some extra data plus my question is called prompt engineering, okay? This is a form of prompt engineering. This is not the only way to do prompt engineering. It is one of the forms of prompt engineering that makes this technique is so powerful, okay? Then it goes to the LLM, which is ChatGPT, Claude AI, Gemini, and it gets the question and it answers it based on all the information it has, right? And that's pretty much how a basic RAG system works, right? Now, more advanced ones might have multiple LLMs at the end for different reasons, but just we're moving on past that. Now, let me explain what a vector is. And your data might look something kind of like this, right? So this could be your data set, right? This is just data set for cost of marketing soap. Let's say there was a company that was selling soap and they're trying to market it. These are the examples of what it would look like, right? Where it might search through. Like let's say if I have a question about how much does it cost to do our content creation, it might pull up this right here, right? If I ask it, oh, like, what are the details involving influencer marketing? Like what goes on there exactly? It might pull up this as an answer, right? But then the answer wouldn't be exactly this because if we augment the answer, this might say, oh, okay, we pay like a range of $500 to $10,000 per month, right? This is what it might say instead of just this raw data by itself. Or you can have it set up to where it spits out the data raw like that if you'd like as well. The system that we built in the code is more raw, just to show you guys what that looks like, and then from there you can make it less raw and things of that nature. So yes, that is pretty much how that is set up, right? So this is like an example of what the data looks like. Now, vectors. Cool. So we have something like this. So this is essentially an embedding, right? An embedding and vector are kind of the same thing, not really. So the embedding is the number version of a word, but not just a number, it's a list of numbers. This word dog has a lot of different attributes. Does it have fur? Is it an animal? Does it speak? What does it eat? Where does it live? Does it run fast? How many legs does it have? Does it have a heart? Does it use the bathroom? What species is it, right? There's all these qualities that the word dog kind of contains in itself. And this list represents each quality. Imagine in a list, right? Each of these things, like let's say this is like, how hairy is it from like 1 to 10, right? This might be how fast is it, right? This might be that it drools. What's the chance that it drools a lot, or how much drool does it produce per day, right? This is just a random example of what these values could represent. It's just each value is represented by a number, like qualities, right? So the way this database works, the vector database, if you looked at it earlier, right, it's chopped up into these boxes, right? The way it works is that each word gets turned into an embedding, right? And then this embedding is how it uses FAISS, the search technique, right? So let's say the way you know that the word dog and puppy are similar versus dog and car and puppy and car is that if you look at the numbers, 12 and 15 are very close. 87 to 88 are very close. 45 to 46 are very close. But 91 to 15 are far from each other. That's a huge number difference. 23 to 88, huge number difference. 11 to 46, huge number difference. That tells you that whatever this word is very different than this word. But when you look at these, since the numbers are so close, that tells you that these words have very similar meaning. They probably look very similar. They probably operate very similar, right? They just have slight differences, right? That's how like this data set is kind of able to find things quickly. So if I say the word, like if I ask it, hey, what dog does the company have? We don't have dogs. We have puppies. It's gonna pull up. It's gonna figure out. Oh, they're talking about the puppy most likely, right? That's how it works. Because if it's hard coded, where it's like, oh, find dog. There's no dog. The AI can't answer. But if we say how many dogs are in this company, we have no dogs. They meant puppies. It'll figure out you're saying puppy, right? If that makes sense. So that's kind of how that works. Another way to look at it is this is like another example. Like this sentence itself gets turned to a vector, right? Or a series of embeddings or whatever you want to call it, right? Where this whole sentence has a meaning to it, right? This sentence has a meaning to it. Depending on the question you ask, which is probably going to be a sentence. It's not going to be a word like hey or why. It's going to be a whole sentence. That sentence has a meaning in itself, and each word's meaning is affected by the word in front of it or behind it, right? Because France is the name of a city, it can be someone's first name, right? Paris is only the city. Capital, that can mean money, that can mean capital city, that can mean different kind of capital. There's a lot of different kind of capitals, right? Mary, oh man, there's so many Marys everywhere, right? So you get the idea of what that means. Roman is another example. Empire, right? BC, that can mean so many different things. It can mean boxing champion. It can mean before Christ. It can mean a lot of different things, right? So that's kind of how it works. Is it saves all those sentences, all of these things, all these points, this cell in the database, in this table, right? So this is a table, and each of these cells is like a data point, right? Each data point is turned into a vector or an embedding, right? And that's how I was able to search through it. And that's how I was able to organize everything very well, very efficient, and search through it very quickly, okay? And that's pretty much how the basic core idea of it works. So I built this code. If you want to follow along with it, just like I said, copy and paste the code from the link below. And you can go to Google Colab. Google Colab, if you don't have the code, you don't need to download anything. You just type in Google Colab right here. Click on Welcome to Colab. Pops up right here. Log in with your Gmail account. Click on New Notebook. And you can just copy and paste the code right here. So you'll see a note, like a notepad. Copy and paste that right here, okay? And you just click on this to run it. And you'll scroll to the bottom, and that's that. Cool. So I'm going to show you. I already ran it at the bottom, and I'll explain how it works a little bit more later in this video. I'm just going to show you it working. Cool. So as you can see at the bottom, when you scroll down at the bottom, make sure you move this to readjust it. Ask your question. So I have a data set right here that's pre-generated, and it's just a random company that's a bunch of company information. I think it's a marketing company for cloud services is what this, yeah, I'm pretty sure that's what I made it, yeah. So I'm asking a question like, what are the departments in the company? And I spelled department wrong on purpose. If you don't believe me, yeah. So let's see. And the output is, what's my question? What are the departments in the company? CEO is Alex Thompson. Direct report, CTO, CFO, VP of Sales, VP Marketing, VP HR. VP Marketing is Alina, and then it kind of goes company, technology goes founded in headquarters, has 150 employees, and okay. Yeah, mission, okay, cool. That's a bunch of information, cool. Now I'm gonna ask it like, how much does marketing cost? Cool. It says the customer support department has a budget of monthly cost of this amount. Yeah, and it's giving me a bunch of more information. Who are the employees here? Who are the employees at this company? And it says 163 total employees, and it starts saying their names, where they're located, and then who is located in Berlin. And they found me everyone that's located in Berlin, Germany. So that gives you an idea of just how a RAG system works via just coding, right? This is just a very, very light example of how it works via coding. Now, how does this work exactly? So, one second, let me scroll up. Break it down. Essentially, this code just represents this. How this is set up is just how the code is set up. A little more, details involved, but the idea is this is the representation, right? Including these concepts are how the code is set up, okay? So if you want to get an idea what the code is doing step by step, right? But I'm gonna go over it very briefly in another video. I will go over this code in deeper detail, but right now I'm just focused on just giving you the general idea of how this code works. So pretty much main, if I can find it, it'd be at the bottom. Def main. So this right here, if you don't know how def main works, this right here is everything put together. So imagine we're building a controller from scratch. Imagine we're building a controller from scratch, right? This final product is essentially what def main is. If each of these little moving parts right here right? Each of these moving parts, each of these buttons, essentially, right, that we have. Imagine those are pieces of the code, and even the shell itself is a piece of the code, right? All these buttons, even the color itself is a piece of code that tells it to be green. The weight is code. It tells it how heavy to be. Imagine all this is code. Def main is all of it combined together. This is the final product. This is the def main. Def main, like def is just a function, and main is the name of the function. This is def main. Okay, that's what it represents. Okay, so all this is this controller. This right here is the on button. So if I press this button, this will turn on the controller, and then I can do everything that I programmed it to do. Right? I can hold it. I can press buttons. I can do all these fancy stuff. Right? That's what this right here. Oh, sorry. I apologize. Yes. So that's what this at the bottom does too. Oh, sorry. That's what this does at the bottom. Okay. Then we need to worry about setup rag system. Setup rag system. Yeah. Cool. Main functions. So everything below this, all this right here, all of this code right here, except everything before main, is the main functionalities, right? So the idea is that all these functions, right? This function, all that Java code right there, is essentially like if I press B, something happens on the screen. If I press A, something happens on the screen. If I move to the left, it falls to go to the left. Like the functionality of this, like if I press this, do this. If I press this, do that. If I like this, letting it be able to even go down, that's actual functionality, right? Let this button go back and forth. Let this button go up and down, right? And I press it, let this button go up and down, right? Be green. All these functionalities, right? Actually, being green is not a functionality, but the idea is that the functionality of this is in that code right there, right? Set up the rag system, right? So, and in the rag system, as we know, looks like this. So we're setting up each of these. If each of these is a node, right? This is a node, this is a node, this is a node, this is a node, or this is a step. Node or step could be called the same thing. That's creating each of those. And you know, this node, for example, where it contains this data, we're creating this too. So in the code, we're creating this on top of that, and we're searching through it via FAISS, and we're querying through it, all that jazz. It exists. All that is a bunch of different things going on, right? Then we're combining this is another step that happens in the process. All of that is what's happening here, okay? Now next we have display all data. So let me show you display all data. Display. Yeah, there we go right there. Cool. So this section here below, all of this, I just wanted to show you guys, like the program will still work if I remove all of this stuff, essentially. If I went like this, if I held control and press the slash at the bottom near the shift key, this disables the code, and the code will still work, right? The whole entire code will still work without this, right? If this was gray, purple, blue, black, green, it still works. It's kind of like that concept, right? Of how it works. It's just showing you guys the data that it generates, right? Because remember I told you I have this code pre-generate data just so you can mess with it. You don't have to download anything. You don't have to, change any files to make sure, guarantee that the file works on your computer. It generates code right there in front of you, and then it prints it. Right? A bunch of these are print statements, which means it just shows you the mock data that it created, okay? That's what that does. And then run interactive. Yeah, there we go, interactive session. This function specifically, it kind of creates like this one specifically handles the talking back and forth. You know how like I ask a question, you listen to me, and then you respond back. That back and forth, that's what this kind of does, running the talking between us, right? That's essentially what this does. And then, if you're done talking, I know you're done talking based off a signal you give me or something you say, or you just walk away. All that is handled right there, okay? It's like the main core functionalities of this code. Now, we're using an AI model in this too. So the AI model that we're using is locally downloaded. We're not using an API call. So this code could technically work offline if you were to fully download the model, but pretty much we downloaded a small version of GPT-2 small. It's one of ChatGPT's old models that it was using before. You can download it locally and run it on your PC because it's very light and easy to use, very simple. And yeah, and then we also use a sentence transformer, which is used to kind of create the embeddings that like this stuff. Like to do all of this and in understanding and similarities and all that jazz, it uses the sentence transformer. Okay, a transformer doesn't mean like the robot transforms or turning water into wine type B. Transformers is just a type of AI, right? Transformer is a type of AI. I'm gonna put it out there so you understand what's going on. Yes, and we're using those two models. So we're using a sentence transformer, which is an AI model, and we're also using GPT-2 Small as our LLM. Okay, so the sentence transformer model is used for this particular part right here. Okay, the search part, that's where it's used mostly, and then the LLM is for answering the questions, which in this case the LLM is ChatGPT 2 or GPT-2, right? To make it simple for you guys to understand. And we have our tokenizer, which is the dictionary that converts everything. And that's pretty much how it works. Yes, ChatGPT. Oh, in this situation, ChatGPT is our generator model. And then the embedding model, the model that handles all the embedding and things like that, that would be the sentence transformer, right? And it's from Hugging Face. Hugging Face. Yeah, and when you run this, you're gonna see a bunch of downloading happening essentially. Don't worry about that. That's normal. Just run it. Let it do its thing. Yeah, like it's all there. Okay, so just keep that in mind. It's gonna take some time to download and start when you first run it, but it should work just fine. Cool. And that is pretty much it for this video, guys. If you want to learn AI from me personally, one-on-one, or in a group setting, or you want me to teach a group, or you want me to help you integrate AI into your business, or you have an idea and you just want to get a cross-reference about if it's a good idea or not in the AI space, reach out to me. My website is linked below. My email is also linked below. So please feel free to reach out. But that's pretty much it for this video, and I really appreciate you guys for listening. Peace.